Hi everyone, my name is Nekesa Grace. In Senior 6 at IGANGA S S, I'm going to take you to number 10, Roman 1 and Roman 2. Our number 10, Roman 1, they require us to calculate the relative velocity of particle A to particle B. I'm going to first of all read for you
We are receiving feedback from maybe machines near you. Presenter, raise your voice a bit.
Our question, number 10, particle A initially at the point with position vector. So we have particle A with initial position 2 in the I, negative 5 in the J, 1 in the K. It's moving with a velocity 1, 3, and 4. We also have our particle B. The initial position of particle B is and it's moving with a velocity BB 3, 0, negative 2. And our first Roman requires us to find the relative velocity of particle A to particle B, which is denoted by F relative to B. For us to get our relative velocity of particle A to B, we are going to get velocity of F minus velocity of B. So we have our velocity A, we have our velocity B. So we are going to substitute. So we have 1, 3, 4 minus velocity B, which is 3, 0, negative 2, 3, 6. So that's what our Roman 1 wanted us to find. Roman 2, they wanted us to find relative displacement of particle A to particle B at any instant after some time. So which is denoted by F RB. And for us to get our relative displacement of particle A to particle B at any instant, like after some time, we are going to have is equals to relative displacement of A after some time t minus that of B after some time t. But then in our question, we are only given the position vectors initially. So we are going to find what RF after some time t is. So for us to get position vector of F after some time, I'm going to get its initial position vector plus its displacement after time t, which we get by multiplying the velocity of F times the time. So we are going to have, in our question, we're given position vector of F initially, which is 2, negative 5, 1, plus its displacement after some time, which we get by multiplying the velocity of F times the time, which is t. So my PF is 1, 3, 4 times t. So when I add this, I'm going to get 2 plus t, negative 5 plus 3t, and 1 plus 4t. So that is the position of our particle F after time.
Can you keep the units, IGANGA, keep the units along?
So we have got the position of particle A after time t. So we also do the same thing for particle B. We're going to get its position vector after time. Its initial position vector plus BB times the time. So we're going to have our position vector, which is 3 plus the velocity of V, which was given 3, 0, -2 times the time. What I'm going to get here is in kilometers. So I'm going to get 3 plus 3t. Here we have a 3. Here we shall have 2 minus 2t. And this kilometers. So for us to get our relative displacement of particle A to particle B at any instant, I'm going to use the formula that I stated at first. I've got this, so it's a matter of just substituting. So we are going to have A relative B times T. I have my position vector of A after some time, which is here. 2 plus T relative 5, 3T, 1 plus 4T. Minus 3 plus 3t. So when I subtract, this is in kilometers. So I'm going to have 2 minus 3, which is -1. T minus 3t, -2t, -5 minus 3, -8, 3t minus 0, 3t, then 1 minus 2, -1, 40 minus 2, 60. So that's what they required us to find in our Roman 2. Thank you for listening to me. Roman 3.
Good morning. My name is Nambuya Shah. I'm presenting number 10, Roman numeral 3. So number 10, Roman numeral 3 says, find the shortest distance between the two particles in their subsequent motion. Now, when these two particles are closest together, when they have the shortest distance between them, the relative velocity of particle A to particle B is perpendicular to the relative displacement of particle A to particle B. So meaning when I get their dot product, it will be the relative velocity of A to B plus the relative displacement of A to B will be equal to 0 when they have their shortest distance apart. But for Roman numeral 1, we found the relative velocity of A to B as -236 dot the relative displacement of A to B, which we got in Roman numeral 2 as -1, -2t, -8 plus 3t, then -1 plus 6t. So this will be equal to 0. When I get this times this, it's positive 2, then -2 times -2t is positive 4t. This times this is -24. Then this times this is 90. plus 6 times -1, -6 plus 30/16 will be equal to 0. From there, my T is equals to 4 out of 7 hours. So this time is the time taken for particle A to get as close as possible to particle B. Relative displacement of particle A to B is given by this, negative 1 minus 2. So here I'm going to substitute 90 as 4 out of 7. 4 over 7. Then here, negative 8 plus.
We are losing the voice.
Then here we have negative 1 plus 6 into 4 over 7. And this bracket, from this I'll get negative 15 out of 7. Then this will give me negative 44 out of 7. Then here, I'll get 17 out of 7. So this is my displacement of A, relative displacement of A to B. But the question wants us to find the shortest distance. And the shortest distance D is going by getting the magnitude of this displacement that I've got. So my shortest distance D is going to be equal to the square root of negative 15 over 7 that squared plus negative 44 over 7 that squared plus 17 over 7 50, and this will give me 7.071 kilometers. Thanks for your attention.